Physics Bites,
Physics Bites,
a science podcast in English by the students of Notre Dame d'Association.
Hello and welcome to Physics Bites, the English language podcast of the students of Notre Dame d'Association here in Paris. We are back for a new episode with our junior level students. In the context of our New Energies project, we have 3 new experts who are going to talk to us about wind energy. So I'm just going to let them introduce themselves and we'll get the show on the road. So who wants to start? Matilde?
Hello everyone, my name is Matilde.
So we have Matilde, and then we have...
Hello, my name is Alicia.
We have Alicia, and our final expert is...
Yeah, and I'm Tatiana.
And we have Tatiana. So Matilde and Alicia, you guys were students with me last year. Tatiana, you were in my physics class, but not in this class. And then this year you decided to join. And that was a pretty good idea because you guys had an absolutely excellent presentation on wind energy. You went over the details of how they work, wind turbines, so what's good about them, what is not so good about them. And then you gave me a list of like 10 startup companies that were doing stuff that I had never heard of. So let's get right into it. How about we start with just a very basic summary of what wind energy is, what are the different forms of it, and then we'll maybe get into some statistics about which countries use it a lot and how much energy we get from it, and then we'll get more into the other aspects, such as the future of wind energy and so on. So who wants to start?
So wind energy is energy that is made from wind, as the name says it.
Yep.
And it's usually with wind turbines. So there are different types of wind turbines, but the most common one is the vertical one with the 3 blades. And so the wind,
which is the one we pretty much see everywhere in the world, on land, in the sea. Yeah.
So usually they're pretty small on the land and bigger on the offshore. Mm-hmm. And so the wind pushes the 3 blades, and so it with the kinetic energy it produces electricity with a generator.
Right, so the basic idea here is that we're converting the kinetic energy this time from wind, and we're converting it to electrical energy through the use of wind turbines.
Yeah.
Okay. What are the different factors that influence how much energy we can produce from these wind turbines? Is there a limit to it? What are some of the factors that go into maybe deciding what size it's going to be? Why are they not bigger? Can they not produce more energy? And all the more technical details, maybe.
Obviously, if there is more wind, we'll have more energy, but it's not the only factor. For example, for the size of the turbine, you have to realize that when you have 2 wind turbines next to each other, they have to be separated by a distance that is long enough to allow the wind to pass through every wind turbine, because if they are too close, the wind will pass through one, and so it will slow down the wind for the next one.
Right. The idea being that the wind turbine is going to absorb a part of that energy, and if the other ones behind are close enough, they're going to have less energy, so it would be much less efficient conversion into electricity. Is that it?
Yeah. So you have to. They have to be separated by a kind of long distance, and it's why they're very far away from each other when you see it on the land or offshore.
Right.
And
let's talk about the difference between onshore and offshore. And last year we actually got to go out to Denmark, and we saw those offshore wind turbines on the coast of Copenhagen. We were able to actually see that there's a notable size difference. Can you just maybe go into some details, or maybe one of the other girls, if you guys want to go into some details about what the differences are between onshore and offshore? Because they look similar, the size is different. I know in France there's a lot of talk about building more offshore wind turbines. Is there a benefit to it? Are there disadvantages to onshore, offshore, etc.? Tatiana, maybe?
Well, I know that building offshore is more complicated because you don't really have a platform to build. So you have to, it is more complicated. You have to build like the platform to put the wind turbine on. But there are advantages. For example, there isn't like a lot of people near, so you can make it bigger because it doesn't disturb people around, and you have, I think there is more wind in the sea because there isn't like trees and
right
buildings that are not
like
helping
obstacles
the wind.
in the path of the wind.
Yeah, so
Right.
it is, there are a lot of advantages, but like the platforms is complicated to build, and I think it is more polluting to build the wind turbine offshore than onshore.
Now, that's one factor that is certainly probably the main factor, is the quality of the wind is different when we're doing it on land and off shore. Can maybe one of you guys just give us a very brief idea of what it is that makes for a good wind for a wind turbine, and what it is that would make wind less, I guess we can call it efficient, or less optimal for energy conversion when it comes to producing energy using wind turbines? So maybe Mathilde, would you like to maybe go into a bit of details about what it is that makes good wind, bad wind, and why we prefer offshore to onshore when we can?
Yeah, of course. So a good wind is kind of, it has to be strong enough, of course, and it also needs not many obstacles, as we said before, because it might just slow down the wind. Also, everything, all of the wind that may that are like breezes are not efficient enough to make a wind turbine function properly. So yeah, and this is why also offshore wind turbines are better than
like on land ones.
Yeah, on land, because as we said, as Tatiana said, there are less obstacles, the wind is stronger, and yeah.
Right, because what happens is, what makes for good wind is the kind of flow that we call laminar flow. And laminar flow is when the fluid flows in like layers, and that requires having no obstacles. And obviously wind coming in from the sea is coming in with absolutely no obstacles, whereas when we're on land, there could be trees like you guys mentioned, there could be buildings, there could be hills up and down, and so the quality of the wind degrades. Okay. So Mathilde, in your presentation, you went on and you talked also about the mechanism by which wind turbines convert into electricity, the energy coming from the wind. Because when we look at a wind turbine, it looks like it's turning pretty slowly, right? And we're like, okay, how can something turning that slowly produce so much electricity? So you talked a little bit about the mechanics of it, right? Do you want to maybe just give us a brief summary of that?
Yeah, sure. So most wind turbines use gearboxes, which allows the base rotations of the blades to be accelerated using gears. So normally it's the blades go from 15 to 20 rotation per minute, whereas the generator just after the gearbox has to be a lot faster, like 300 rotation per minute. And so the gearbox allows the rotations of the blades to be accelerated enough and to be synchronized with the generator.
Right. By what factor does it usually increase the number of rotations? Do you know?
The factor?
How many, like once it goes through the gearbox, how fast would the turbine be turning inside in the generator?
I think it's something like 300 rotation.
Okay, so it's a big factor of increasing the rate of rotation. Okay, and you also mentioned that this is the main source of problems with wind turbines usually comes from the gearbox?
Yeah, because they are really weak, fragile, and they can have crack. They over time they get cracks inside, and these are very expensive to repair. And because it is just very high, it is also dangerous for the men to climb on these platforms, and the materials are very expensive, so it is not the best solution for the moment.
Okay, and we saw that last year also when we visited the offshore wind turbines in Middelgrunden, that they've kind of run the course of their lives. It's been about 20-25 years, and they were saying it's very expensive to do any kind of repairs, or because they're offshore. And so that's another problem with the offshore wind turbines, right? Okay.
Absolutely.
So I'm going to come back to Alicia. So maybe before we go into more details, do you want to maybe talk to us about, in general, what the different types of wind turbines we have are, and then maybe to follow up on what Matilde just said, what some of the inconveniences of these this source of energy could be?
So there are lots of different wind turbines, vertical or horizontal. The vertical ones, like I said, are really the one we see the most on land or offshore in your life. And so they can be, like we said, land-based or offshore. And the most powerful one is the Haliade X. That is long. I think it's around. I don't remember the size of the plates, but they are really long.
Okay.
And it has a power between 14 to 15 megawatts, as a normal one has between 1 and 3, so it's really more efficient. And so there are horizontal ones, but we don't see them as often as the vertical ones.
How does that work, the horizontal ones? Because the vertical ones are easy to see. You have this big giant pole. It sticks up in the air about 80 to 100 meters, and then you have the three rotators, and we can see them pretty much from everywhere. They've become something that we see most of the time when we're traveling now. How does a horizontal turbine work, wind turbine?
Because the blades, when it's horizontal, you turn like when the wind blows on one blade, it takes all the others to turn. Well, a horizontal one in general has 2 blades, and it's so there is more surface, that the wind can push through.
Okay.
But usually it's smaller and it's used in the cities because the wind is more focused on one direction because
Right.
around there are buildings, and so it focuses like on the roads usually, and so it's when wind it's usually in one direction. It can no for the vertical ones, the wind can go in any direction, and the turbine turns
Okay.
to not face the wind.
Right. So this is the problem that we might have, is that wind can change directions. And
Yeah.
with the conventional wind turbines, you're saying that it's kind of complicated because then we have to turn them around, if possible
Yeah.
at all, to face the wind. Otherwise, we can't actually produce any energy from it. With these
Yeah.
horizontal ones, you're saying that the direction of the wind makes absolutely no difference because they will turn regardless of what direction the wind is coming from, which is what makes them slightly more advantageous. But before we go into more new kinds of wind turbines and different kinds, can you just go over some of the reasons why wind turbines might not be an ideal form of electrical production? What the inconveniences could be, either you or Tatiana?
Well, there are some risks of the usage of this energy because some wind turbines fall because they are really high, and it's an unsure energy because wind doesn't blow every time, but always.
Right. This is what we call the problem of intermittence. The idea that it's not something you can always count on. It's not always present, or it's going to be pauses. And it's sort of a problem with some renewable energies, mainly wind and solar. Go on.
Also, they are really really high, and you need a lot of machineries to install it. And also, for people living around wind turbines, there is a syndrome called wind turbine syndrome.
Right. What is this wind turbine syndrome?
Well, people around the wind turbines, they can feel dizziness or nauseous.
Okay.
Just we learned this when people tell us that around wind turbines they feel more sick than not. Also, it produces a lot of noise for people around.
Right, but so this is, I think, kind of debatable because remember last year when we went actually on the wind turbine in the water, did you hear any noise?
Not really, but when you have like all the wind turbines running at the same time, it makes noise for people like when they're really close.
Okay.
So it's just a problem for people living in the neighborhood.
Immediate vicinity of it. Okay.
Yeah.
Okay. You also mentioned a few problems. Well, we talked about the mechanical failures, which lead to a short lifespan, which is about 7 to 10 years. And you mentioned also that they're not as environmentally clean as we had thought. Do you want to maybe give us a bit of details about what that means?
So first, there are problems with the disposability of the LX because the material used are not recyclable.
Right. This is mainly because of the transport. I think is part of it. Is a huge part, right?
So
take them easily from one place to another.
Yeah, and you need a huge installation to like bring it on the site to build it, and also to destroy it. You need really big machines, and it pollutes a lot.
Right. But then you also went into afterwards. We'll come back to it. Some startups who have made it their mission to try and reuse these wind turbine rotators for other uses, right? And I think what it was one other major problem with these wind turbines, and you mentioned it. You said the average power production from most is about 1 to 5 megawatts, right? Is that a lot?
Not really. And you need a lot of wind turbines to produce not so much energy. And so right now the wind turbines use a lot of space because, as I said, they have to be distanced from each other, and so it uses a lot of space and to produce not really a lot of energy. But there are some that produce more energy, like I said, the Heliod X, or just offshore. They are more efficient. But yeah, so there are problems with the energy that it uses for us to build it, and well, it doesn't produce as much as other
which means that it's going to take up
sources.
more space to produce the same amount of energy, right? For example,
Yeah.
compared to nuclear energy, which is much more efficient. The amount of space that wind turbines would take to produce as much energy as a nuclear power plant would be many square kilometers more, which would cause a problem when it comes to land use. Okay. You guys also talked about the upgrades which would be possible for the future. So the way to sort of make them more efficient or have new designs, completely new ways of doing it. Do you guys want to go into that maybe a few minutes before we move on to all the prototypes for new types of wind turbines?
Yeah, I
So,
can.
Mathilde, yeah.
There are actually a lot of upgrades that we could do in the future. So first, the most obvious, make the wind turbines bigger and or higher to capture more wind, or add more helix also. The huge problem nowadays of, as we said earlier, wind turbines are that they are not possible to recycle
Right.
because they are made of composite materials like carbon, and so there are some startups that are trying to recycle those components. So, for example, the helix, which are made in composite carbon. It is really hard and expensive for the moment, but it is not impossible, and maybe with more research we could make this technology cheaper and be able to generalize it worldwide. There is also the possibility to use wood for wind turbines.
Oh, really?
So it's kind of surprising, but it could work. It do works actually. So the perks of using these materials would be that the production will be more eco-friendly than
Right.
making
And I suppose the material is biodegradable as well.
Yeah, also it is strong as steel. Yeah, it's surprising also, but it's a nice thing.
Okay. I also remember that when you guys were presenting, you talked about the idea of wind turbines would be more efficient the higher up they are. Is that something?
Yes.
So I guess that's another way of trying to optimize the way we produce wind energy, electrical energy from wind.
Yeah, but it is also it can cause controversy because even though it's higher, people might complain for like the fauna, because it's wind turbines kill some birds, and if the wind turbine is higher and bigger, it might cause more problems.
Right, but that is also one of the complaints, I think, from anti-wind turbine groups, is that they kill a lot of birds, especially birds that go through migration.
Yes.
Which is true, but from, I think, the numbers that we've seen, it's much less than we think in terms of the proportion, right? So
yeah.
But if it is going to be higher up in the air, it could have a bigger influence on like migratory paths of birds. Okay. So I think we've gone over most of the general idea here. Maybe we can move on to the final part where you guys presented a ton of like new companies working on very experimental stuff. I think Tatiana was the one who mainly went through the list. It was quite surprising how many new ideas there are being worked on. So just to see what I've done in my notes, you talked about O-Wind, Heirloom, Wind Catcher, Power Kites, Brainware, Enerkites. So do you want to maybe give us a short rundown on one of so basically just tell us what each of these new ideas are and how it would be beneficial?
Oh, so the O-Wind is like a ball. It can be put in villages, on top of buildings. It is not as big as wind turbines. It produces not as much energy. That's like it is like a ball. It turns it turns like practically in every sense, so it can capture most of the wind that goes by. It is small. It is more pleasant to look at. Then we have the Heirloom. So the Heirloom is I don't know. It's outdoor. It has to be built where there isn't a lot of people around. So it is like a state where it is oval, and there are like blades that are turning, so it produces energy. I think it is 50 kilowatts per hour. I
remember this was one of the more weird ones that you showed us.
Yeah.
So you basically have like a little track, and on this track are these individual vertical blades, and they're all running around on this track from the wind, and it looks kind of really strange, and you wonder how it could produce energy efficiently, but apparently there are a few prototypes of this running around, right?
Yeah, there is a lot. There are some prototypes that are already built. It produces energy, but like I said earlier, it is not as much as wind turbines. It is. We are thinking to make it more efficient, but for now, it is less efficient than wind turbines.
Right. So it's an idea. It's a new way of thinking about it, which is very different.
Yeah.
The question is, will it get somewhere which will have some advantages or not? That remains to be seen. Okay.
Yeah, well, maybe.
What were wind catchers?
Well, wind catchers, it's like a panel of small wind turbines. It is, I don't know, there are around 50 small wind turbines on a panel that works. It works the same as a big wind turbine, but it catches more wind around, because they are small and they cover more space. So they are usually offshore. they are usually offshore, and the only problem is that it can't make birds pass through. But I think it's the same as to wind turbines.
Right.
It's
So the
just
idea
that
being
it will catch.
here you have this sort of a giant panel we're thinking about, maybe 30, 40 meters high and
Yeah.
across, like a grid. And on every point on the grid is a tiny little 3-bladed wind turbine. So on the whole catcher, you'd have maybe 20 or 30 little wind turbines turning. And I suppose the idea here is to be, how would you say it, more efficient in the cross section of the air that you're catching.
Yeah. The only problem is that if we build a wind catcher, there wouldn't be a lot of wind after.
Right.
So when it crosses the wind catcher, we can't build another one after because there wouldn't be a lot of wind
left.
Because the wind catcher.
And these are mostly offshore?
Yeah.
Okay.
Onshore it is more dangerous, and that is why it's usually offshore.
Okay. You talked also about a few airborne technologies. So by airborne technologies, we mean catching wind energy high up in the air, like not connected to the ground, right? Okay. Do you want to maybe go briefly over those?
Well, they are looking like planes. I would say they are up in the sky. They're usually attached, and so when they are up in the sky, they fly with the wind, and so they catch the wind because they make forms like 8, and it produce energy that are later made into electric. So there is like canoes. Those really look like planes. We also have the brainware. It is like
brainware.
a loop.
That was an interesting choice of name, right?
Yeah. It is like a loop with blades that we make fly, that catches wind, and we have inner kites. They look like kites that we use for fun, but this one actually produces energy. And yeah.
So the key, I suppose, in most of these is the idea of, instead of we said earlier that the higher the wind we get, the better the quality of the wind. So if we want to catch winds that are high up in the atmosphere, it's very difficult or impossible to actually have our wind turbine connected to the ground. So we're finding, I suppose, different ways of having flying wind turbines. Is that the general idea? Right, so either they're in the form of kites with like a little cords connected to the ground, or actually flying around like a glider or something of that nature.
Yes.
Okay. You also talked about, if I'm not mistaken, you talked about wind turbine walls?
Oh, yes. Well, wind turbine walls, it's like the same principle as a normal wind turbine, but it can be built in cities. It's, as the name says, it's a wall with turbines in it. The only thing that isn't as great is that it doesn't really produce much energy, and the company that made this wall doesn't give any more information about it. So it could produce up to 50 kilowatt per hour, but it's like not really pleasant to look at. So the idea isn't.
I suppose
really...
it is sort of similar to the wind catcher idea that we mentioned just a few seconds earlier. Okay, but more for
it's just smaller, and the blades aren't vertical; they are horizontal.
Okay. You also mentioned another one which I found really, really interesting. You'll maybe tell us about how actually efficient it is or not. Right, the ridge blade.
Yeah.
What is that all about?
So the ridge blade is like a mechanism that is put on top of roofs of houses because of the degree of roofs. The wind is faster, and so the ridge blade catch more energy that it could when the roof is horizontal. So it is pleasant to look at. It isn't really visible, and it can produce a lot of energy because the roof accelerates the wind.
Right, because of the tilt of it
going through the ridge blade.
Okay, that was interesting. I remember we looked it up, and it looked actually kind of. It doesn't look like it could produce a lot of energy, but according to the website, at least they were saying that they've done tests and it can get a pretty decent amount of energy out of it. Okay.
Yeah.
So I think we've gone through most of what you guys talked about in your presentation. Have we forgotten anything? Is there anything any of you guys want to bring up that you found you either didn't have the time to present during the presentation or that we haven't brought up here? Matilde?
We did researches about also the financial aspect of the wind turbines.
Right. Okay. Well, let's get into that very quickly, maybe.
Yeah. So for the moment, the cost of wind energy in France is estimated at €1 per month per household. This represents the annual cost of supporting wind energy for a household consuming 2.5 megawatts per hour per year. The CapEx, which stands for the capital expenditure, for onshore wind, ranges from 1 million euros to 1.7 euros, depending of the height of the turbine's blade.
Mm-hmm. Okay. What is the percentage globally of energy that we're producing from wind? Do you guys know?
We don't have it worldwide, but per country, yes. Well, we don't have the exact percentage, but we have the exact number for France in 2021, and the wind turbines produced up to 18,000 megawatts. Compared to 2005, for example, it was not even 1,000. So
we know that there has been a very precipitous growth in wind energy, especially in Europe. I suppose in France here, it's a specific case because we do produce a lot of energy from nuclear, which means that we have a pretty clean sort of electricity. So we haven't had the need to transform our energy bouquet, if we can call it like that, like countries like the Nordic countries or Germany. Is there a good future for wind energy in your opinion, the three of you guys? Is this an energy for the future? Is it always going to be a sort of secondary source of energy? Is it something that we can count on more to complete other main sources of energy, or is it something that really has a true future?
I think personally that this type of energy is really promising.
Mm-hmm.
However, of course, there are we can't always count on this because the nature, we can't control nature, we can't control the winds. But I don't know, because we saw that there is the possibility to create batteries, like huge batteries to stock the electricity produced when, I don't know, there is a lot of wind, for example. So I won't go into details, but it uses what we call a vacuum chamber flywheel. And it's very efficient, but for the moment it's only for short time energy storage, so we can't maintain it for a long period of time, so we didn't find yet the proper way either to stock it or to produce energy and be sure that it would be accessible at any times. So,
in general, I think one of the main problems that we have, another group of your classmates who are going to talk about entirely just about ways of storing energy. In general, I think the main problem with a lot of these more clean, if we can call it like that, and renewable energies is the problem of intermittence. So the one way to fix that problem is through the question of having industrial level and scalable energy storage, right? Like the flywheel concept that you're talking about. But we're going to get into that into more detail in another episode with the group that presented that. Okay, so as usual, my final question for you guys in these interviews is what you guys found particularly interesting, what it was that you discovered that you didn't know about before doing this research for this, and if somehow your opinion was changed or modified or something. Because we had, for example, the group who was working on nuclear energy, and they all had very interesting and wrong ideas about nuclear energy and its dangers, and then they were all converted by the end of it. So I'm curious how it turned out for you guys. Are you guys advocates of wind energy? Did you know something about this before that was wrong? Maybe we can start with Alicia.
Personally, I think that wind energy is promising, but I didn't know how that the production of the wind turbines isn't really ecological, and that there are problems. We can't. I think we can't call it clean energy because it produces a lot of pollution for, like I said, creating the wind turbine and installing it.
The fabrication and the manufacturing process and the transport.
Yeah.
Okay.
And so I didn't know that that this was so much not ecological. I don't know how to put it, but
no, it's not very not as environmentally friendly as we had thought.
Yeah, because it is renewable energy, but with the short lifespan, we have to use a lot of materials that are not recyclable.
Right.
To create a wind turbine. So I found it interesting that there are different faces of this energy, and I didn't know.
Okay. Tatiana, what was your experience doing the research? Did you find something that you didn't know about? Are you a convert to wind energy, or are you more cautious like Alicia?
Well, the thing that I didn't really know about wind energy is the prototypes
Right.
Before I did my researches, I thought that there is only like wind turbines with 3 blades. There are the most common ones. And when we did our research, I was shocked by the numbers of prototypes and different blades that exist for wind energy. I think it could be promising because yes, wind turbines uses a lot of place. It isn't really ecological, but
Right.
we have a lot of prototypes that are more ecological than wind turbines, and so there is a future for it because when our planet is we have climate change, and so we really need energy that is clean, and we can make it possible. I think it has a great future.
Okay.
Yeah.
I think this is the one thing that most people don't think about when we talk about renewable energies is that, okay, while the functioning of these forms of energy might be clean, at times the quantity that we have to produce or the time it takes or the complexity of the thing usually is where the main source of carbon emissions are. And I guess in something like wind energy, because we have to produce so many because they are not very high density in terms of energy and power, in the end we're producing much more pollution and carbon than we had thought, and in indirect ways. Okay. Matilde, maybe to finish off the interview, what did you discover that was new to you, unexpected? Are you converted? Are you dubitative about wind energy?
It was a very interesting experience for me to make all of this research because at first, to be honest, I was kind of disappointed with the subject because for me, wind energy was kind of basic. But when you go further into the researches, you take conscious, you become self-aware that become aware that there are a lot of as Tatiana said, really interesting and silly prototypes, which are, promising or just kind of strange.
Right.
But also to look deeper into the how does a wind turbine works. It was really interesting, and for me, I absolutely loved all of the researches that we did for this.
Well, I'm glad to hear that, and I think you guys did a really interesting presentation. It was quite different from the other ones with the focus that you guys had on all these very weird and innovative ideas. Because I think wind energy in and of itself, there's nothing particularly fancy about it, but to see that there's a lot of ideas out there, even if they might be kind of silly as you put it, it's still kind of reassuring that we're not going to be stagnating. All right, so thank you very much to all three of you guys. It was a very fun interview and great presentations. I hope you guys enjoyed it as much as we did. So thank you very much.
Thanks.
Thank you.
So that is Physics Bites for this week. We hope that you enjoyed this episode, and we would love to hear what you thought about the topic in the comments section. If you did enjoy the show, then subscribe to our podcast, share it with your friends, and be sure to leave us a 5-star rating on whatever platform you're listening on. And more important than all of that, come back soon for a new episode.